Yeah, I am Sanchita, um, and I am a data science and analytics professional. I'm working at a private bank, and today I'll be touching upon the topics of logistic regression and decision tree analysis. These topics are quite close to me because I'm an economist by degree and by training, and an analytics professional by experience. So just adding on to that further, I would like to touch upon these topics and take a session on these. So should I start? Okay, so starting with logistic regression. Logistic regression is a model which has been used in traditional statistics as well as in machine learning. So it's a very hot topic these days whenever we talk about classification problems. And in the case of classification algorithms, logistic regression and decision tree, they are the two very famous models which I use. So I thought that I'll cover these models today. So coming to logistic regression, it's actually derived from the family of generalized linear models. So a linear regression model, for example, is a very simplistic regression model in statistics. Second, coming on to the logistic regression, it's derived from a linear model, but it's basically a classification algorithm where the response variable is binary, or it can be multi-class. But how is it different from a linear regression model is that here the predicted variable, the variable which we are predicting, the target variable, is in a class format, or it is a categorical variable and not a continuous variable. That is a major difference between a linear regression model and a logistic regression model. So linear regression basically will be used to predict a continuous variable. For example, sales or price. There are real estate property prices, a hot topic these days, that, like what is the price of a property, predicting that from where you can earn greater profits and stuff like that. So for example, size and weight of a person, predicting the price. So all these variables, these are continuous variables. So linear regression is used to predict these variables, whereas logistic regression is used to predict a categorical variable, which can be depicted in the form of like true or false, yes or no, 1 or 0. So for example, if the weight of a person is suppose 70 kgs or 80 kgs, will we tag him or her under the obese category or not? So here the categorical variable is it's a class variable. So classification algorithm derived from the word class. So here the target variable is into a class format. And the logistic function basically is derived from inserting a sigmoid function, unlike a straight line in case of a linear regression. So now we understood that what is a linear regression problem, but still there would be questions asked that, but still kya ho gaya? Why can't we use a linear regression for classification? Is that the only reason about the predicted variable? So first, definitely that's a main reason, that the predicted variable needs to be continuous in case of a linear regression, unlike a logistic regression. But what can be the other reason for it? So the other reason is basically, as you can see a straight line over here, like this is an arrow, it's a straight line. So basically the green dotted points are the points which we use in the logistic regression. These are random points, sorry. So these are just random points. And in case of a linear regression, suppose if we need to predict a class variable by using a linear regression, then we try to fit a line of best fit on this model. So while trying to fit in the best fit line, we get this red straight line. As you can see in the picture, this red straight line is the line of best fit as per a linear regression model. So you can argue that, okay, fine, we are using this line and this can predict the model. Okay, fine. But consider a case where there is a value which is given on the extreme right of the axis. For example, at the end of the axis, for example, if I take X as the weight of an individual and the dependent variable would be, I'm categorizing if the person is obese or not, then X, for example, is 150 kgs. So a person weighing 150 kgs, if I try to use that here in this line, so I will get a point in the outlier segment, which will be like way ahead, y is equal to 1, right? So one point why we are not considering linear regression for these kind of problems is the impact of outliers. So when an outlier is signified in a data set or categorized in a data set or found basically in the sample set, then linear regression cannot deal with it when the predicted variable is a class variable or is a categorical variable. In that case, it cannot handle, a linear regression cannot handle such cases. That is why we are using logistic regression here. Second point is that this line goes till the negative axis also. And this line goes on to positive infinity as well. So here we are saying that we can get values varying from negative infinity to positive infinity. It means that we can also get, for a person who's weighing 10 kgs, we can get a y value of maybe minus 10, which is not possible, right? We cannot classify a person who's weighing 10 kgs as the obesity ratio to be minus 10. We either need it either 0 or 1. So again, a linear regression fails in such a case where we are not able to actually categorize it into 0 and 1. So therefore, here comes the logic of a logistic regression, wherein we say that, okay, fine, we are getting a set of values and we are imposing such a function for those values, which will help us to segregate the class of that particular variable, like whether that person will fall into 0 class or whether that person will fall into 1 category. So here, like I've also done a working, I'll just show you the working. So I am sorry, I'm not a very good artist. So, I mean, I would urge you to forgive me for my really bad handwriting and bad drawing, but I think that this is actually the best way to, explain. So, for example, I'm coming on to the logistic regression graph and I'm trying to explain this. So here, the logistic regression, the logic behind is that we operate on the threshold values and the probability values. So suppose in the prediction, the model run hota hai, to predicted class mein we get a set of probabilities. So in that probabilities, we have to find a threshold value कि अगर उस threshold value के ऊपर जाएगा तो एक certain class हो जाएगा उसका, और उस threshold value के नीचे अगर कोई probability lie करती है तो एक दूसरा class हो जाएगा. So that is how we are dividing it into two classes, two categories. So here, for example, this is 0.5, correct? And for example, I find that this is 75 kgs or 70 kgs, whatever. These days, people are a lot into yoga and dieting, so probably 70 kgs, right? So I can say that if a person is 70 kgs, then the probability or the threshold or the probability is 0.5. And now, if I set it as a threshold value, then I can say that a person who is above 70, these cases, for these cases, the threshold value or the probability, the probability value will be greater than 0.5 and it will be less than 1. So here, it will lie in this area. So all the people who are lying in this area, they will be categorized as 1. It means that they are obese. And all the people who are less than maybe 70 kgs, they will be categorized, they will lie into this area, and the probability will be less than 0.5. So they will be categorized into class 0, which is not obese. So basically the graph is derived this way, and it's different from a linear regression, because here linear regression में क्या होता है, there are various points, right? अब ये line is a continuous line. So here there are various points and a line of best fit is inserted over here. Now, when a line of best fit is inserted, we say कि Acha chalo, this is the line of best fit, and we said ki how did this line appear? We use a different logic of the residual error in this case, and we minimize the residual error, and for whichever line the residual error is minimized, we select that line. So here we are selecting, suppose, this line, and we say कि अगर अच्छा x की value ये है तो y will be this, x की value ये है तो y will be this. So again, this is a very continuous derivation of the target variable, continuous hai. Unlike this, we are not dividing the target variable into categories over here, unlike a logistic regression where we are. So again, a mathematical explanation of the graph. Simple graph ka explanation ye hai, and how are we dividing it into 2 categories. So again, in the PPT, as you can see that I have given a segregation of linear regression and logistic regression. So here, these are all the points which I have told you. So again, it's a straight line, it's a S-curve, sigmoid function, logistic regression. And here, basically, we take the possibility of a particular event taking place in case of logistic regression. And here, we are just talking about the change in the dependent variable upon a unit change in the independent variable. Here again, it's a straight line, it's a S-curve, and here the OLS method is used, ordinary least square, which I already mentioned, that we minimize the residual error. Here the maximum likelihood method is used for the estimation. So maximum likelihood, in case of maximum likelihood, we see that which is the curve. So again, you will find many curves like this, like this. So for whichever curve, the multiplication of all these probabilities will be maximum, we will select that as the sigmoid function. For example, over here, the residual error to be minimum is the criteria. Here, the maximum likelihood function. It means that the multiplication of all the probabilities needs to be maximum for that best fit sigmoid function. So that is something which we get over here. So again, we use a logit function, and there is a concept known as the odds ratio. It is basically the probability of success to the probability of failure, where here P is the probability of success and 1 minus P is the probability of failure. So here the log of odds ratio is actually depicted as a straight line, and upon further derivation, we get P as this equation, which is E of A plus BX upon 1 plus E of A plus BX. So this is actually the y-axis when you see a function like this. So coming on to the performance of logistic regression, I will also, before turning on to this, I will also turn on to the practical implementation of the logistic regression model. It's a short demo though. I have taken a very basic data set, but I will show you that. So before moving on to the decision tree, I will have a short demo of that as well. So here, here we are focusing on the performance of the logistic regression model. So now we know that how the logistic regression is derived, what is the function, the logit function, and basically what is the use case over here, and why are we not using the linear regression, and what is the maths behind the logistic regression and the interpretation of this graph, basically. Now coming on to the performance of the logistic regression. So now we have run the logistic regression and now we get a certain output. And what are the metrics? What are the evaluation metrics which we use to evaluate a logistic regression model? That whether, like, what is the fit of a logistic regression? What is the accuracy level? And how did our logistic regression model perform? So here, for example, the first is AIC. So in linear regression, I don't know how many of you are from a statistics background, but in statistics, there is a concept known as adjusted R square, where R square is basically the, like we minimize it. It's basically the minimum of the residual error which we get. So analogous to that in logistic regression is AIC, which is an information criteria. And we prefer a model with a minimum AIC value. Second is a confusion matrix. Here, a confusion matrix is given. So here, I would like to take some time and explain this. So here, a confusion matrix may we get 4 kind of values: a true positive, a true negative, a false negative, and a false positive. So suppose in the data, in our data, the actual value or the actual class is divided into 2, good and bad. So when the actual class is good and the predicted class is also good, then it's a case of a true positive. Short form is TP. And when the actual is good, but the predicted is bad, then it's a false negative. And why it's a false negative? Because it's actually a positive value. It's actually a good case, but we are categorizing it into a bad case. So it's a false negative. When the actual value or the actual actual class is bad, but the predicted is good, then it's a false positive. It means that a certain attribute or a certain set of attributes were actually categorized as bad, but they were predicted as good. Now that is a case of a false positive. And when the actual is bad, but the predicted is also bad, then it's a case of true negative. It means it's correct. There is no error over here. Actual was bad, predicted is also bad. So, for example, a person who is maybe 110 kgs and that person is obese, right? So in actual data, it will fall into this category of bad. But the logistic regression model gave it as a good category. It means that the model categorized it as a non-obese person. Then that is a case of a false positive. So false positive and false negative are also type 1 and type 2 errors in the linear regression model. But maybe when I'll take a session on the linear regression, then I can explain that. So here I'm not going very deep into the type 1 and the type 2 error, but the false positive and false negative, they are actually a signification of that. They actually signify that. Yeah. So here, what is a TPR, which is a true positive rate? So that is actually given by D upon D plus C, which is true positive upon true positive plus false negative. And FPR, which is a false positive rate, is given by false positive upon false positive plus true negative. These two. And the derivation of this is basically used in the ROC curve. So ROC curve is the receiver operating characteristic. It is one more performance metric of a logistic regression model, which we actually see to to depict that how the logistic regression model is performing. So here, the ROC case is given, it's a function like this. And here, it is actually depicting the false positive rate, the points of false positive rate and the true positive rate. So you can get these points. Basically, a x to y coordinates, and out of that you are building a curve. So a ROC curve is a metric, it's a very important metric, and basically a model which is performing good will have a ROC curve which is tilted above this 45-degree line. It means that the greater the ROC, or the greater the area under the curve, which is also known as AUC, the better the model is. And what will be a perfect model? A perfect model will be at this point where there is no false positive, matlab kuch bhi galat nahi hua, and there are only true positive cases. So it's here, it signifies that it's a perfect model. So the more curved the ROC is, the greater degree to which it is tilted above this 45-degree line, the more better the model is. We also have concepts of precision and recall, and the F1 score. So the F1 score is nothing, but it's the harmonic mean of the precision and the recall. So they are also important metrics which we use in our model. So now coming to one depiction of the logistic regression model. So in the logistic regression model, we are using a very famous data set, and you will find this data set, you will easily find this data set on GitHub or Kaggle or many other websites. So it's a very small data set, and it's just a sample data set with not much of feature engineering. I have used this basically to amplify on the logistic regression part and not focus much on the EDA part, which is the exploratory data analysis. I'm not covering that in this session. And I'm also not covering too complex feature engineering. That is because a lot of time is actually taken up in complex feature engineering and the complex EDA. Therefore, I've taken a short, sweet and simple data set, and on that I'll be performing the logistic regression. I can also send you the code of the logistic regression after the session, or maybe analytics Vidhya can help me in that, help me in distributing the code.
Sure, we will be sharing the code for sure.
Yeah, thanks. So here I'll just share my screen. So here I've already written the code. I have run it and I've given the output also in the PPT for the decision tree, and for the logistic regression, I'm running it in front of you. For the decision tree also, I'll show the implementation part in a demo form. So here, first step in Jupyter, we are using Python for running the logistic regression model. Here, firstly, we are importing NumPy as MP, then as import pandas as PD, and then importing Seaborn as SNS. So basically, Seaborn is a data visualization library. Pandas, again, it signifies a data frame. So basically the usage of data frame, in that we have to use pandas. And NumPy, for performing all the mathematical functions, we are using NumPy. So here in the second step, we are basically reading the text file over here. It's a CSV file. So pd.read CSV, the data set, and this is the data set. It looks like this. Third step, we are checking if there are any null values or not. So again, I have not delved too much into the EDA part. That would have taken like half an hour or 40 minutes altogether. So I have taken again, reiterating that I'm not doing much of EDA over here. So here I have taken, so here I'm checking that if there are any null values in this. So sorry, I'm not running it. Yeah. So first we load the libraries, then we read the data set, Then we check if there are any null values or not. So here 0, 0, 0, it means that we do not get any null values. Then we are seeing the length of our data frame. It means that basically how many rows we have in the data set. Then we are seeing the shape. What is the size of the rows? What is the size of the column? It's 14 and 6. Then df dot head basically depicts that we get the top 5 rows of the data set and all the columns. Tail again is the last 5 rows. Then this is the basic description of the data. What is the count? What are the unique values? What is the frequency? So here, basically we use sklearn library for importing pre-processing. So it's basically a data processing tool, which is the label encoder over here. And why are we using a label encoder? Because, for example, temperature is mild and hot, humidity is normal and high, wind is weak and strong. So we are just giving it labels. We are encoding it into labels here using sklearn. So basically, these were the string functions. These were string, normal, high. These are words, weak, strong. These are string functions. Now we are converting it into integers. We are applying string to integer, and then we are transforming these variables. So again, done this, and the new data frame is something like this. After that, we divide data into the attribute set and label. So what is the label over here? Label is basically the target, the variable which we are predicting. And feature calls are basically the feature columns. So in statistics or in the data set language, basically the input variables are also known as they're also called the attributes or features. So we run the model using all the attributes, and the target variable is basically the dependent variable over here. So in our case, in our data set, the target variable is play, because and the input variables are outlook, temperature, humidity, and wind. So here it's not only about playing tennis, but for playing any sport, we basically need to see that how is the weather forecast, what is the temperature, what is the humidity, what is the wind like. For example, you cannot play badminton if it's too windy, right? And if the temperature is soaring, or if it's too hot, and if you're facing scorching heat, then obviously you won't go out to play. So these are a set of variables. Again, humidity is also one factor. So outlook, temperature, humidity, wind, these are the factors which we use to decide whether we are going to play or not. So these are the feature columns. So again, this is X. X depicts the feature columns, which are outlook, temperature, humidity, and wind. And Y depicts the target variable, which is that depending on these, a combination of these, whether I will go for playing outside or not. Then in case of logistic regression, what we do is that next step is that we are dividing it into training and test sets, splitting the data basically. So again, a brief on that, why are we splitting the data, is that because we want to train the model. Now for training the model, we cannot train the whole model, right? So in that case, what will we predict then? So we are training 75% of our model, and 25% basically is the test category, which the data on which the model is not performed, and we will just test it to basically signify that how well our model has performed or how correct our model is. So here the train and test split happens. And here we are performing the importing of the logistic regression, again from sklearn library. So here we are naming the variable as classifier is equal to logistic regression. And here we are fitting the trained model. And these are basically the parameters. So I have not tuned any parameters. Again, tuning of parameters would have involved greater time, and we already short on time. I'm way ahead my portion as of now. So we are using this model to train, and we are not tuning any parameters, and we are just treating these parameters as default parameters. So we are fitting the model, and after that, we are predicting. So the model is done, and now the next step is predicting of the X test. We are predicting the test data now. And coming on to the metrics which I just covered in the PPT, here we are seeing that how is the model performing. So basically, like what is the accuracy quotient? So here the accuracy is like 75%. And here again, it's there are 4 values in the test. So again, my data set was very small. So only 25% of the values could be used in the test. And here, for example, just a brief, the actual was 1, the actual class was 1 and the predicted was 0. So here we are getting this false. Actual was 1, predicted was 1. This is correct. Actual was 1, predicted was 1, and actual was 0, predicted was 0. So out of these 4 values, 1 is where we are getting a false result. The other 3 are positive, or we are getting a true result. So 3 out of 4 is 75%. Therefore, the accuracy rate of 75% we are getting. After that, we come on to the confusion matrix. Here, I talked about true, positive, true, negative. I explained it to you in the PPT. So basically, I talked about the precision, the recall, the F1. So here, this is basically the confusion matrix. So logistic regression, we are done with the implementation part. Now coming to the decision tree. Okay. So again, what is a decision tree? So now we are digressing to the second classification algorithm, which is a decision tree. So decision tree and logistic regression both are categorized into supervised learning technique, and they both are used in classification. Decision tree is also used in the regression problems as well as the classification problem. So why it is called a decision tree? Simple, right? Because you are taking a decision on the basis of a tree. That is why a decision tree. So although it's not that simple, because there are a lot of technical jargon terms involved in case of a decision tree. But the idea basically is that we are splitting the data sets on the basis of various features. And we start with the root node. And the decision tree starts by asking a question. So this was something interesting when I was actually learning it, and I was learning it myself, reading through all the articles, seeing the videos and everything. So what is a decision tree is that basically it starts with a question, right? And after, so for example, just treat it as a person asking that question. For example, if I am asking a question and if I'm satisfied with that answer, then I will not further, delve deep into it. So similarly, a decision tree, when it asks a question and when it is satisfied, it will not split further. But if it says that, okay, fine, I want to delve deeper into the question, then it will split further and further and further. So again, the terms are basically that we start with a root node, which is also known as a decision node. And decision node is basically the first feature on which the splitting starts. And then we come on to the subtrees and the leaf nodes. So basically, after the decision node, a splitting happens, and the end of a subtree is a leaf node. Why a leaf node? Because at the leaf node, no further splitting happens. That is why, so it's called a leaf node. And basically, this is the, so this is a part of the subtree. Next is parent or child node. Parent or child node is also known as a root node, which is also known as the decision node. Parent node is from where the tree starts. So basically, a decision tree is a supervised learning technique. All the points which I've said earlier without a screen visible, they are the points over here. Again, I was talking about a decision node and a leaf node. So decision node is also known as a root node. And here these are the leaf nodes. Leaf node is a part of a subtree. After the leaf node, no further splitting happens. So you can see that this is the end. This is also the end. This is the end. And why this is the end? Because we got a satisfactory output over here. It means satisfactory output means that we were able to segregate all the samples into one class. I will depict that later on also in my output, but basically no further splitting happens when we are clear with the class. If we are not clear, then we will split it further. Then coming on to the attribute selection measures. Now, how will we, suppose we have a set of all the variables in the plate NS data set also. We had outlook, temperature, humidity, wind. So on what basis will we decide that which attribute we should select and which attribute will come where? So for that, there are various techniques used. One is the information gain. Basically, this is used to decide on the root node, and one famous technique to decide that from where the data will actually start. Second is Gini index or entropy. So again, in my code also, in my Python code, you will see that we can employ both these methods, and I will also show you how we are employing both the methods. So we can employ either the Gini index or the entropy as a attribute as a parameter of the decision tree. So here again, the information gain, as I had already mentioned, that it's a node or the attribute which is having the highest information gain. It is split first. And there is a certain formula which we use to find out the information gain, which is given over here. If I would have had more time, I would have actually shown you the calculation of the training data set over here, which is the plate NS data set. And I had actually shown you the rough work, but it's fine. Basically, we are using this formula over here to find out the information gain. And entropy is basically a metric to measure the impurity in each attribute. Similar to Gini index, that is also a measure of impurity. So it is said that we should take that feature which has a minimum Gini index. That feature should actually be selected in a tree. So entropy formula is minus P of yes. Yes is again a class, yes or no. So basically these are the positives. Then log of probability of yes, then probability of no, and then log of probability of no. And then coming on to the Gini index is given by a formula of 1 minus P square. P is again the probability. So here basically it is a decision tree working. So here in our plate NS data set, we are actually finding as to which node will we select first. So we have 4 variables with us, right? Like output, temperature, and humidity and wind. So out of these 4, which factor will the tree finally split, or what will be the root node? So here basically we are using the Gini impurity. Gini index also it is said, but according to the sklearn library, it is a Gini impurity. So I mean, you can call it either ways. So Gini impurity or Gini index is calculated again by this formula. So again, although we do not have much time, but I will just touch upon this to give you a brief introduction, and you can actually do a mathematical calculation of this. And the reason behind choosing a small data set was also that we could easily do a mathematical calculation. So here G1 is basically 0.48, which is 1 minus 2 by 5 square minus 3 by 5 square. So as I've already mentioned that Gini index is basically 1 minus P square. So here P is the probability. So here, if we take outlook, yeah. So for example, G2 is 1 minus 0.4 whole square minus 4 by 4 whole square. So here, if we are taking overcast, suppose as an outlook category. So here, I am just signifying overcast, overcast, and overcast over here. So here, this is yes, this is also yes, this is also yes, and this is also yes. So there are 4 yes, and there are 0 no's. So G2 is given by 1 minus 0 by 4 square minus 4 by 4 square, which is 0. Again, G3 is when we are considering other categories of sunny and rain. Here again, G1 is other category, sunny or rain. And now we are calculating the weighted average of G1, G2, and G3. So the weighted average here is 0.342 of outlook, basically. And how did we, if you are wondering, how did we get 5 by 14 and 4 by 14 and then 5 by 14? So basically, outlook is divided into 3 categories. And overcast, there are 4 cases, and the total number of cases are 14. And out of overcast, there are 4 cases. So that is how we are getting 4 out of 14 over here. And for sunny and rain, there are 5 cases each. Therefore, we are getting 5 by 14 and 5 by 14 over here. And then these are the weights, and then we are multiplying it by the G1, G2, and G3 values to obtain the 0.342. Now, as you would have clearly remember in the previous slide, I mentioned that wherever the Gini impurity or the Gini index is the lowest, we will select that feature. So here, after all the calculations, we find that outlook, the Gini impurity for the outlook is the lowest. So this basically becomes our root node. And the first step becomes like this, where the outlook is divided into sunny, overcast, and rainy. Now, after this, again, we are doing this calculation to find out that which feature will be the next feature. So after this, we talk about the advantages of the decision tree and the disadvantages of the decision tree. So basically, again, as I mentioned earlier, it is the process which a human follow while making any decisions in life, right? So you remember that our elders or our teachers, they've already said that, in your mind, make a flow chart that, what you're aspiring to do, how will you do it? So basically things are achieved by making a flow chart. Decisions, the decision making process. So basically it's a form of that. So here we are just using Python for that, and you make flowcharts every day in your brain. So you are actually running a decision tree model every day in your brain by making a flowchart and then abiding by it. So disadvantages may first, the most important is actually a overfitting issue. Overfitting issue में क्या होता है? In that case, there are a lot of layers. The depth is like too much. So what happens is that we just keep splitting the decision tree into layers and layers and layers. Sometimes, for example, if at the end of the decision tree, I get 21 and 2. So out of 23, if I know that 21 are yes and only 2 are no, then I can simply categorize it into yes, right? That the output of this is yes class. So I will disregard the 2 cases because they are very minuscule. But sometimes overfitting happens and we do not stop the decision tree till we get 0 in one class. Either we get 0 in no or either we get 0 in yes. So till that time, we just keep splitting the decision tree. So that is actually a problem of overfitting, and that's a very major disadvantage. For that, what we basically do is that we fix a maximum depth. So again, tuning of parameters includes one of that includes fixing a maximum depth of the decision tree. So again, we have used a play tennis data, and what I'll do is that I'll just quickly go through the code So here again, we start with loading of libraries, import NumPy as NP and import pandas as PD. Then we read the data set. The data set appears like this. And then again, we are doing, we are importing label encoder from sklearn. And we are running it. Then we get the play tennis, the data set, including the output. Then here, what we are doing is that we are dropping the target variable over here to again get the feature columns, barring play, which is the target variable. So the feature columns become output, temperature, humidity, and wind, the same case as the logistic regression. Here, I'm importing tree again from sklearn, and I'm giving a variable of CLF to the decision tree classifier. And here, as you can see, I have mentioned the criterion as entropy. Entropy was given in my PPT, where I've given the formula also of entropy, although the calculation is depicted of Gini, but entropy calculation is also not very tough, especially for a small data set. Here, random state I've selected as 0, and the maximum depth I have selected as 4. So not more than 4 levels of segregation I need in my data, in my decision tree. So here CLF is again fit of X of Y. In the decision tree model, where X are all my feature columns and Y is my target variable, which is play. Here again, I'm plotting the tree, and filled is equal to true means that I get colored columns. So that is the significance of filled is equal to true, and plot tree I'm using as a function. Oh my God, where did my tree go? Yeah, so here's my tree, and I have depicted a very neat output in my PPT. Just let me know if my PPT is is visible.
Yes, it is visible.
Okay. So yeah, here's my decision tree output, where X0 is outlook. If you remember in my feature columns, that was actually the first variable which I had mentioned, and X1 is temperature, X2 is humidity, X3 is wind. So basically, the most important feature as depicted in the calculation also was outlook, and my decision tree via Python, the output which I get on Python is also depicting the same. So here again, I am getting outlook X of 0 as the root node. It is basically the decision node where the first splitting happens. After that, so here entropy is depicted as 0.94, and in my model, just 1 minute it will take, I can change the criterion to Gini over here and then run the model again. So here again, instead of entropy, Gini is written. And here again, we are starting from the decision node of outlook. Yeah, so here entropy is given. While the so if you will calculate the entropy and the Gini index for this particular data set, you will find that the Gini index is lying between 0 to 0.5, while entropy lies between 0 and 1. So I've also made a simple graph for you to understand. So this is basically the Gini impurity, and this is basically the entropy. There it lies between 0 to 1, and Gini is from 0 to 0.5. So in the decision tree, entropy is mentioned as 0.94. The samples are 14 because I've not done any splitting. I have taken the full data set. And here in the first instance, the entropy we get was 0. So here there is no further splitting. Why? Because the value which we get is 0 and 4. 0 and 4, it means that in one class we get all 0, and in one class we get all 4. It means that we know that what is the class of this particular section. So here we are not splitting it further. Here we are splitting it because 5 fall in yes and 5 fall in no. So that is how we are splitting it. And again, we are splitting it further into, okay, so X2 is humidity. So after outlook, when you are doing the calculations again of Gini, you will find that after outlook, the lowest Gini or the lowest entropy is for humidity parameter. So that is how the second split is at humidity. So at this point, again, it is split into outlook and it is split into wind. So when X2 is humidity, when it is less than or equal to 0.5. Now, humidity less than or equal to 0.5 is normal because high is 1. In the label encoding, we have mentioned high as 1 and normal as 0. So when it is less than 0.5, it means that the the humidity is normal. So when the humidity is normal, after that, again, on the basis of that, we cannot take a decision, right? So then we will come on to the outlook. And we will also come on to how windy it is. So again, the wind is weak here because wind parameter is less than or equal to 0.05. And outlook less than or equal to 1.5 means that it is rainy. So again, this further splitting keeps on happening. And at the end, with the maximum depth of 4, we get this output, where, as you can see, the class is 1, 0. It means that in one category, we get all zeros, and in one category, we get all the other values. Here also 0, 1, here also 1, 0, here also 0, 1. So these are called the leaf nodes because here no further splitting of the decision tree happens. So this basically ends my brief introduction, or basically a brief depiction of the logistic regression and the decision tree. I have used these reference links. You can find these in my PPT. You can go over these articles as well. In the end, I would just like to show you one video. If it works, then it's good. So here, basically what we do is that we basically we fit the function, we fit the odds ratio into a logit function. And if you're asking that how this sigmoid function is derived, then it's basically derived from the MLE, which is the maximum likelihood estimator. And the coefficients are basically A and B. So on that basis, we derive the sigmoid function.
Okay.
If I could get clearly the question.
We can move to the next question. So Microsoft I'm sorry.
Yeah, no problem. It's just the maximum likelihood estimator I just said.
Okay. So we'll move ahead with the next question. Microsoft Excel makes a use of polynomial regression when fitting a trend line to data points on an XY scatter plot. Excel multiple regression. May you help explain curvilinear regression and relations to Euler number E, power laws, logistic regression, and then from linear regression to nonlinear?
Oh, it's a very complex question.
Yeah, exactly. Even I was not able to understand much. Do you want me to paste this in chat? Otherwise, you can see it in the Q&A part.
So should I randomly pick questions?
No, it's up to you. Or like you can go in the sequence how it is.
Okay. So basically, how do we pick the maximum depth for a decision tree? So again, it's basically it is a part of tuning of parameters. And I had taken a small data set. That's why I had taken a maximum depth of 3 or 4. If it's a very large data set, then maybe you can have a greater number, a larger number, maybe 8 or 9 also will do, depending on the size of your data set. Then maths behind the logistic regression and the decision tree. So here basically, So here basically the maths is that when we are applying, yeah, so here when we are applying log of p upon 1 minus p, so log p upon 1 minus t takes various values. So we get a axis from -1 to 1. And on that axis, we get a straight line, straight linear fit, and we get -1 to 1. And this is a plus bx. I'm not writing it, but it's a plus bx. So the coefficients being a and b. On the basis of these, for example, if we take a value, we insert that value here in this function. And when we are inserting this, we get a certain p value over here. So that p value is basically the dependent variable value here on the y-axis. Now this, when we are inserting the values of -1 to 1 in this function, you will notice, you can apply a formula and also notice that we will get the values between 0 to 1 only. Although these values are -1 to 1, but when we are using these values here in this function of p is equal to this, we get the values between 0 to 1, and hence the logistic regression formula and the math behind it. Well, if analytics Vidhya want, I can have a different session altogether on just the maths, or I mean, it will help me learn also, because
Sure, we can absolutely have another session as well. You can get in touch with our team and we can schedule one for sure.
and similarly for tuning of parameters as well, the maximum depth and everything. So again, the criterion, the maximum depth, the random state, all these are parameters. Similarly for EDA also, I have not I did not get the time also to actually take a complex data set and do all the EDA.
So EDA can be a little extensive, so it is understandable.
Yes.
But yes, surely, as I said, you can get in touch with our team and we will schedule a session accordingly.
Yeah, definitely. And this complex question, curvy linear regression in relations to Euler number E law logistic regression, then from logistic regression to non-linear. I can actually delve deep into it and then explain probably. As of now, it won't be correct if I give you an answer. So let me learn also and then probably answer this.
Okay, and also like guys, if you get any questions later on, you can surely get in touch with her on LinkedIn. We have shared the LinkedIn link as well, so you know it will help both of you.
Just 2-3 questions I'll take. Just I think 2-3 minutes of your time, Priyanka.
Sure, absolutely.
Yeah. So why recall is 1? So recall is basically the ratio of true positive upon true positive plus false negative. So when we are getting only the true positives and when the false negative is 0, in that case, the recall is 1. So in that case, the accuracy of the model. So we are getting all the true positives. So in that case, the recall is 1. Who decides the cutoff for the performance indicators? See, I have employed few decision tree models in my work till now. So basically, 0.8, 0.85 is considered to be a good model. Above that is considered to be too good to be true. But on an average, 0.75, 0.8, 0.85, 0.89, they are considered to be metrics which indicate a good performance of the logistic regression model. Which is a better metric? Gini index. Okay, so which is a better metric, Gini index or entropy? So entropy, since entropy involves log in the formula, it is usually not recommended for huge data sets because the computation time is much more in case of entropy, in case of a log formula. So only for a small data set, generally entropy is recommended, but there's no hard and fast rule. Gini index is again recommended for large data sets. The computation is less cumbersome in case of Gini index. How to arrive at optimal number of tree size? Again, it depends on the data set. Usually, when the data set is very large, you take more number of maximum depths. Now, gradient descent algorithm is a different model altogether. Okay, I think this question, which case DT is useful if logistic regression is efficient and DT, when to use logistic regression and all. I hope that this question was answered by my video, because my video showed this thing only. So I think I can share the video also with the analytics with their team, and they can further distribute it probably.
Sure. Yeah, absolutely.
I think this question was answered in that video, because in that video I showed that when to use logistic regression and when to use a decision tree basically. So yeah, I think काफी कुछ तो हो गया cover. इसके बाद तो नहीं है कोई questions.
Yeah.
Thank you so much everyone for actually attending this session and staying attentive also, because I could see questions being asked. So it's actually really very nice if you see questions being asked and an active participation. So thanks a lot for taking out time.